Hi, my name is Leonardo Frid, and I'm going to be guiding you through this brief tutorial on spatial models in SDSIM. Before starting this tutorial, you should complete the previous tutorial called Getting Started with SDSIM, which will guide you through building a simple non-spatial model in SDSIM. For this tutorial, we will be working with the data set that is created as part of that tutorial. I should also remind you that for this tutorial, you should be using SDSIM version 3.0.34 or later. We'll be covering a few topics during this tutorial, including a review of the basic model inputs, working with folders to organize your scenarios, and running spatial simulations and viewing the output for these simulations. Now, to run this tutorial, you're going to have to open up your browser and navigate to synchrosim.com. If you go to the tutorial page looking at the menu on the left, you'll be able to find the previous tutorial, and underneath that there is a link to downloading the data set that was created as part of that tutorial. So I'm going to click on that. Now, while that data set downloads, I'll just point out that synchrosim.com is the main page or main website for documenting synchrosim. It is here that you can find a reference guide, publications of previous model case studies, and the actual methods in the development of SDSIM. So I'm going to go to the publications page right now and just link to the main paper describing the SDSIM methods called State and Transition Simulation Models, a Framework for Forecasting Landscape Change. This is a paper that was recently published in Methods in Ecology and Evolution. And just as a reminder, I'm going to show you the simple model that was created in the previous tutorial. So this is figure 1 in the model, and if you recall, we created this simple model for a forested landscape where each cell in the landscape can be described according to two variables. Its vegetation state being either deciduous in yellow, mixed forest in brown, or coniferous forest in green, as well as by its age. And the numbers besides the letter assigning a cell in this landscape to each state represent that cell's age. Now that we've downloaded the data set created in that previous tutorial, I'm just going to show it in the folder and extract it. And I'm going to extract this data set to my documents. So this zip file contained a single SSIM library file. Now to view that model that was created in the previous tutorial, we can open up synchrosim either by going to the Start menu and navigating to synchrosim version 1, or we can just click on the icon here on my toolbar that I added when I installed synchrosim. Once synchrosim is open, I can go File, Open Library, and again navigate to My Documents and scroll down to that SDSIM tutorial SSIM library and select Open. Now because this Getting Started tutorial created that library in an earlier version of SDSIM, I'm being prompted to update the library to the current version that I have installed. And I'm going to click Apply. Now we have the tutorial library open, and if I expand the library node inside the scenario management, I can see that there's a single project contained in this library, and that project contains two scenarios that we created: no harvest and harvest 20 acres per year. Now I'm going to be going over some of the basic inputs that we created inside this scenario, and just as a point of comparison, I'll show you on the right side of my screen the diagram representing the model that was created as part of this scenario. Okay, So again, as a reminder, this forested landscape has a potential of 3 possible states, and each cell also tracks its age. So if I open up the harvest 20 acres per year, we can see all of the inputs that were represented in this scenario. First of all, I'm going to click on the Run Control tab. Now this set of inputs defines the starting time step and end time step, so the length of the simulation, and also the total number of iterations. And for this tutorial, I'm going to be modifying these values. So we're only going to be running the model for 10 time steps, and we're only going to be running the model for 10 iterations. The next tab represents the transition pathways. And so if I click on that, we can see a tab for the entire forest vegetation type or stratum which we are modeling. And we can see 3 different boxes representing the 3 states that are shown on the diagram on the right. I can also view information associated with transitions, or what can lead a cell to change from one state to another. And I can do that by either double-clicking on one of the boxes, and so we can see at the top information about whether there's any change in the cell according to a deterministic transitions at the top. In this case, there isn't. Or according to probabilistic transitions, that is, transitions that can occur with an assigned probability for each time step. In this case, there's 2 possible transitions for the deciduous state. There's either a fire probability that is possible, which may occur with a probability of 0.002, or about a 500-year return interval. And after the cell reaches an age of 10, then there is a 10% probability of transitioning to mixed forest. Now, for this example, I'm going to bump up the probability of fire to quite a larger number of 0.05, so a 5% probability. And I'm going to do the same for the other 2 states as well. So rather than a probability of 0.005 for the mixed forest, I will assign a probability of 0.1. And for the coniferous forest, I'll assign an annual fire probability of 0.2. So these are much larger numbers, and I'm doing this just to be able to show a larger amount of area undergoing this type of transition in the spatial model. Now, the other input that is required is a description of what the landscape looks like at the start of the model run. So we can see that in the diagram on the left, we show that the landscape at time 0 is starting out with each cell assigned to a particular vegetation state. And over time, individual cells will transition in terms of their states because of the occurrence of specific transition pathways, either succession, fire, or timber harvest. And those changes will also affect the age of the cell. So to define the initial conditions in the model, we go to the Initial Conditions tab. And here we tell the model how many acres our landscape represents, how many simulation cells will be used to simulate that landscape, and also the composition of that landscape. So what percentage of the landscape is in the different vegetation states and age ranges. Now, this is a model where we apply timber harvest. And the way timber harvest is applied in this model is by using transition targets. So if I click on that tab, here we tell the model that we want to apply an area target of 20 acres per year of timber harvest. I'll leave that set as it is now. So to be able to take this model that was run non-spatially and turn it into a spatial model, I'm first going to create some folders so I can organize my scenarios inside this project. So I'm going to right-click on the project, and I'm going to select New Folder. And this folder I'm going to call Non-Spatial. And I'm going to take the 2 scenarios that I created in the previous tutorial and drag them into the non-spatial folder. I'm then going to right-click again and create a new folder, and I'll call this folder Spatial. And then I'm going to take the second scenario, the one we were just looking at, which included harvest and for which we changed the number of time steps in iterations, I'm going to right-click on it, copy, and paste it into the spatial folder. Once in the spatial folder, I can reopen that scenario. And to be able to do a spatial run, I'm going to change two inputs. I'm first going to turn on the checkbox to run the model spatially. So rather than running the cells non-spatially, now the model will represent cells in space in a raster that looks very much like the one that we have on the right, except the initial conditions of each cell will be defined randomly according to the initial conditions distribution that is set in this table. Now, the last thing I want to do is I want to tell the model what kinds of outputs I want to see, both in terms of non-spatial outputs. So I'm going to select I want to see states every time step and transitions every time step. But I also want to see spatial output, and I'll see spatial output for both states and transitions every time steps, as well as ages, and I will also select to view the average annual transition probability. And this last one, I will select to view only for the last time step, so that it's summarized across the entire run time period. I'm now ready to run the model. To do that, again, I'm going to right-click on the scenario I want to run and select Run. I'm going to be prompted to save the model, for which I will say yes. And so now we see the progress of that run occurring on the bottom left-hand status bar. Once the run is complete, I can view results associated with that run. Now you'll recall in the previous tutorial we created two charts, one for states and transitions and the other for the age distribution. And I can show you the states and transitions chart, and we can see, we can even compare that to the scenario that was run in the previous tutorial. So I'm going to right click on that and add it to the results. And now I'm just going to expand the window so we can make all of the chart windows a little bit bigger. So first of all, the red scenario is a scenario that was run previously non-spatially. If you recall, we had much lower fire probabilities. And you can see that right away on the right chart here at the top, where we have the amount or the proportion of the landscape undergoing fire being much larger for the blue scenario that we just created, as opposed to for the red scenario, which we ran previously with lower fire probabilities. This in turn really affects the distribution of states on the landscape. We see much less coniferous, much more deciduous, much less mixed. And that makes sense because fire is stand replacing in this model and returns all cells to a deciduous state class. Now, in order to view maps, because this previous scenario is non-spatial, I'm just going to remove it from the results. And I'm going to click on the Maps tab and create a new map. And this map I'm going to call States. Actually, I'm going to call the first one Transitions, to show how transitions are occurring on the landscape. And rather than showing it just for the default time step number 10, I'm going to show them for the time steps 1 through 10. And I will just reorganize the windows, and I will expand the transitions node and show a map for each fire, harvest, and successions transitions, and select apply. Okay, so you can now see over time we have a panel for each time step and a row for each type of transition. We have fire at the top, harvest in the middle in yellow, and succession transitions at the bottom. And I can pan to the, or scroll to the right to see those maps for each time step. Now you'll recall we also ran multiple iterations. So this is displaying the transitions that occurred during iteration number 1. I can toggle the little buttons here to show other iterations. I can also zoom in if I want, and I can pan. And note that when you pan one of the panes, all the other panes are panned so that you're viewing exactly the same location of the landscape. Now the other thing that really jumps out when you view these charts is that the transitions are happening independently one cell at a time. And that's because we haven't really defined how cells interact with each other in this model. In future tutorials, I'll be showing you how to do that. For now, I'm also going to show you a map of what the states and ages look like over time. So again, on the Maps tab, I'm going to click on New Map, and I'm going to call this one States and Ages. Click OK. And again, I will resize this so we can see it a little bit better. And under Basic, I'm going to select the state class and the age box, and again, time steps, this time 0 because we have our initial conditions through 10. And I will hit apply. And so at the top, we have the top row represents the states on the landscape over time, and the bottom row represents the ages of each cell over time. And we can see how those are changing. And as we have more and more fire, you'll notice the landscape getting younger and more deciduous over time. Less mixed and yellow-blue cells. Now, if you don't like the colors that are being displayed, let's say again we want to make the colors more similar to those in this diagram, I can go and set deciduous to orange, mixed to brown, and conifer to green. And the way I do that is either by going to Project Definitions or clicking on the Definitions icon, going to States, State Class, and here, again, we want to set deciduous to orange. We want to set mixed to brown, and we want to set coniferous to green. And I can now hit apply on the chart, and the colors are updated on the legend. So we can now see the states changing over time. Finally, the last chart I want to be able to show you is how does the probability of particular events look like across the entire time period. And so for that, I'm going to be clicking on, again, the Map tab and selecting a new map. This one we'll call Fire Probability. And I'll click OK. Resize the window a little bit, and that one will just show for the final time step the average annual probability of fire, and select apply. And so here we have a range of values anywhere from 0, so these were cells that didn't transition at all across any of the time steps or model iterations, all the way up to 0.17, so cells that transitioned on average just under once every 5 time steps across all time steps and iterations. And that is the end of this particular tutorial. Now the next tutorial will show you how to create interactions between cells in the model run so that what happens to one particular cell affects its neighbors. So you can try that tutorial in a short little while. And finally, I'm just going to end by, again, going back to the SynchroSim page. So this website is really the documentation for SynchroSim and STSim, and includes a reference guide and tutorials. And then also, if you go to ApexRMS.com and have questions, as a registered user, you'll be able to post questions and get answers to them on our forum. Thanks for listening, and we hope you try out some of our other tutorials.